And now, let's see how to calculate the elasticity. Specifically, how to calculate the price elasticity. So we know that is the response. Right? So we are going to measure the response of quantity demanded due to a change in its own price. So what we need is the slope, right? Those who have done mathematics, you may have a good idea how to get the response. So maybe you may remember even we did in our O level. Right? So we had something like this. We had y here. We had x here. And then we had the graph. Let's say for simple one like this. Now how to get the slope of this curve? This one. Simply, we can get delta y by delta x. Right? What is the change in y due to a change in x? That is what we did. In A level also we did. When we wanted to get the slope of a curve, we did that. And those who have done mathematics in your A level, of course, you may have done a lot of exercises with that. Right? Simply we say the change in the dependent variable. Y is the dependent variable due to the change in the independent one. So this change by itself, that change makes some impact on y. So that is what we mean by the slope mathematically. Yeah? Then in this demand analysis also we can do the same thing. We can look at the change in P, which is the independent, and change in Y, which is the dependent. But I told you, we made the mistake from Adam Smith. We have changed the axis. So here we are having not Q, we are having P. So therefore, we get the inverse of the slope, which is given by delta Q by delta P. So simply forget about this graph. We will be taking this graph only. Right? If we take only this graph, we are having price here, we are having quantity here, and then we have different prices, P1 and P2, Q2 and Q2 and Q1. Now we need to get the slope. Since we are interested in inverse of the slope, so we are going to get delta Q by delta P. Right? So let's put some value here. Let's say this is 10 and this is 20. So original price is 10 and the new price is 20. So original quantity, let's say this is 4 and this is 2. For example, so let's say this is 2. Now we are having 2 points, right? We have price 10 and the respective quantity is 4. And price is 20 and the quantity is 2. Let's say this is about sugar, right? So when sugar price is 10 rupees, there will be 4 kilos demanded. And when price increased to 20, we have 2 kilos demanded. Then what is the slope? What is the slope of this? Delta Q, it is 2 divided by delta P, it is 10. So 2 divided by 10, it is 0.2. Yeah, very correct. So we are having 0.2 as the slope. So that's the slope. So can we say this is the elasticity? 0.2 is the elasticity in this case. Of course, if we get the slope, that is true. But in economics, we are not satisfied with that. Because in mathematics, this is okay, no issue at all. But in economics, we are not accepting this because you see, there will be certain differences. For example, let's say this is price 10, that is okay, as previous. And this is price 20, that is also okay. And then quantity was, instead of kilograms, what I do, I will put grams. Right? No issue. Instead of kilogram, I can put 2000 grams. Still the same. 2000 grams mean, let's say grams means 2 kilograms. It is the same. For 4 kilograms, I will put 4,000. 4,000 grams, right? So instead of 2 kilos, I put 2,000 grams, and 4 kilos, I put 4,000 grams. So the unit of measurement is changed. In economics, that can happen. Unit of measurement will change, grams, kilograms, and then tons, and then liters, milliliters, rupees, cents, dollars, then pound, euros. Likewise, there will be different measurement changes. In this case, what I did, I just changed it from kilograms to grams. Now, can someone calculate and let me know? Here I will put the previous one because scale is better. 10, we had 2 here and 4 here. If this is the case, when we move from A to C, it was 0.2. Now, can someone calculate this one quickly? What is the slope? Change in quantity is now 2000. Change in price is 10. Right? One thing you need to remember, change in price is same, 10. Change in quantity was also same. It is 2 kilos, but in grams, that is 2000 grams. Now, what is the response? 220. There are 2 cases. 2000, and then delta Q is 2000 divided by, and this is 200. Yes. Oh, this is 200. Now you see the problem. If we use just the mathematical definition of the slope, we can take the slope. That is the response. Mathematically, of course, no issue at all. But the problem, when we change the unit of measurement, the elasticity values are different, which I did not discuss yet. Here it is 0.2, which is less than 1. We say inelastic. If we are having a price elasticity of demand like 0.2, the numerical value 0.2, we say it is inelastic. If it is like 200, which is much higher than 1, then we say it is elastic. So we have the same change. We have same change, 2 kilos change, and same change in price. Price is 10 rupees. Right? When we change price with the same amount, quantity have the same change, but in different measurement units, kilos and grams. When we put into grams, it is 200. When we put into kilograms, it is 0.2. So which is to be accepted, whether it is elastic or inelastic? Because in economics, there's a huge difference. When we say elastic, you have one meaning, and when we say inelastic, you have another meaning. Therefore, we have to decide which to be accepted. Which to be accepted. Of course, economically, we cannot accept any. Right? We don't agree with both these calculations. It is just the slope will not help us to get out from the problem. Therefore, in economics, we are worrying about the proportionate. Right? So we are not happy, we are not satisfied with the previous slope calculation there because of the unit of measurement. This one. When we change the unit of measurement, of course, that changed the elasticity of demand. So we are worrying about the proportionate change. This is why I define price elasticity of demand as proportionate change in quantity demanded due to a proportionate change in its own price. And so this is the definition for price elasticity of demand, this one. We have proportionate change in quantity demanded divided by proportionate change in its own price. If we do that, of course, we can ignore the unit of measurement problem. So there what we do, we see the proportionate change in quantity demanded due to, with its original price. What was the original price and then what is the change? This is known as proportionate change. The price also the same. What was the original price and then what is the change in price? So then we divide it by this one. Then we get the price elasticity of demand. For easy calculation, we have rearranged the equation. Then we get price elasticity of demand equal to delta Q divided by delta P. That is change in quantity divided by change in price multiplied by original price and original quantity. Right? Initial price and initial quantity. Right? So we have this one. Additionally, now we are having delta QD divided by delta P multiplied by initial price divided by quantity. Now can we get back to the previous example? This one. 10 and 20, we had here 200, we had 200 here, 2000 here, and here we had 4000 in grams, and we had the same here, 10, 20, and here we had 2 and 4. Let's assume we are moving from A to C, capital A to C. So, original price is 20, original quantity is 4000. And then we are having here 20 as original price, moving from simple A to C. Then initial quantity is 4. Can someone calculate the price elasticity of demand from moving capital A to capital C and simple A to simple C quickly and let me know the values? The same thing, delta Q divided by delta P multiplied by initial price divided by initial quantity. What is the price elasticity of demand for this case? Capital at this point. What is the answer? First case, it is 1. This one, eh? It is 1. Then what is the value for the second one? If you are moving from simple A to simple C. The first one is wrong. Not 1. It is multiplied by 20. This should be 2, not 1. This one should be 2. And this one should be, the second one should be, we are having 2 divided by 10, 0.2 multiplied by original price is 20 divided by, this is also 2. The correct answer for this, here we are getting 2 as the price elasticity of demand. So here we are getting 2 and here we are getting 2. Now, what I wanted to say here, when we get a proportionate change, of course, we have no any difference. Right? Whether it is grams, here we did with the grams, 2000 grams and 4000 grams. Here we did with the kilograms, 2 and 4. When we did the calculation, you can do it easily, delta Q by delta P. So change in quantity demanded divided by change in price multiplied by the initial price and initial quantity. If you put this equation with the two cases, you get 2 here and 2, right? So whatever the measurement unit, finally your elasticity will be the same. So it is elastic. Greater than 1, whether it is kilograms or grams, we can say it is elastic, right? Therefore, now we have no any worries. Now we are okay. If we get the proportionate change in quantity demanded, then proportionate change in its own price, then we get the final answer, which is known as point elasticity of demand. In this case, what we are going to do, we are going to get the elasticity for a particular point. For point A, it was 2, and simple A, it was 2, right? Then, is it okay? Can we happy about this? Happy about the point elasticity? Or just by looking at this, can we say the response is 2? Still not. It is because if we keep the same example, where we are having price, 20 here, 10 here, and we had 2 here and 4 here. Price elasticity of demand was 2. It is same here also, so I forget about this part. So now I am worrying about this, right? So here what we did, we changed price from A to C. It is a price decrease from 20 to 10. When we had the price decrease from 20 to 10, price elasticity of demand was, right? Okay, calculation again. I think I will be using my board. In fact, I'm having some troubles when I use this one. So here what I did, we have the demand curve like this. So we had 2 points. Right. The initial condition was here. The price was 20 and 10. Quantity was 2 and then 4. Right. So let's assume we are moving from point A to point, I will put B here. So I just wanted to move from point A to B and calculate. Right. The previously what I told you, we had delta Q by delta V multiplied by P by Q. That part is understandable. If we just get the inverse of the slope, it is not the slope, it is inverse of the slope, because we are having Q here. This is the independent axis. In the independent axis, we are having the dependent variable in this graph only. Therefore, what we are going to get, we are going to get the inverse of the slope, delta Q by delta P. But we understood that with the measurement unit, right? With the unit of measurement, when it moves from grams to kilograms and kilograms to gram, there can be different estimated values of the elasticities. Therefore, we are not going to do that, right? For our example, we calculated in one case it was 200, the other case it was 0.5. Then whether it is elastic or inelastic, we were not sure. Therefore, the final equation we used was this one. I hope that part is clear. If it is not, also please let me know. I will explain again. But the point that I wanted to explain here, now we are moving from A to B. It is a price decrease. When there is a price decrease, there is an increase in quantity demanded. So therefore, first let's see the delta Q. Delta Q means change in quantity demanded, which is move from 2 to 4. Initially it was 2, now it is moving to 4. Right? So delta Q is equal to 2. And delta P, I hope you can see it. Delta P equal to 10. You just put those values. Right? Delta Q equal to 2, delta P equal to 10, and get the initial price. Because this is the point we are interested. Right? That point is 20. and the particular quantity is 2. Now solve that. So it is easy, 2, and it will be 2. So price elasticity of demand at this point equal to 2, which we call in economics as the point elasticity of demand. Point elasticity of demand because we are estimating the elasticity at this point, the response at this point, because it is the initial point. We are moving from A to B, so this point is known as the point we are interested. So the point elasticity of demand at this point is 2, right? Which is known as point elasticity of demand. That is equal to 2. If you calculate those values with 2000, 4000, still you are getting the same. Not to worry, you will be getting point A equal to 2 because it is, we have the delta Q as 2 divided by 10 multiplied by 20 divided by 2000. Now, the point which I wanted to raise here, instead of moving from A to B, which is a price decrease, now you can have a price increase, moving from 10 to 20. Right? Instead of moving from 20 to 10, now what we are going to do? We can move from 10 to 20. There's a price increase. When we have a price increase, of course, we see a decrease in quantity demand. Originally it was 4, now it is 2. Right? Can you calculate now what is the price elasticity of demand? Now we are going to check the price increment, not price increase. So now we are moving from point B to point A. What is the price elasticity of demand if it is the case? This part won't change, delta Q by delta P. Delta Q, it is 2. Delta P, it is 10. But this part will change. P by Q will change because now initial price is 10. Initial quantity is 4. Now what is the price elasticity of demand? You just do, and it is 0.5. Here, 0.5. Now see the problem. Now we are having another problem here. You have the same change in price. 10 rupee change in price, 4 kilos change in quantity. But see the price elasticities. Here, when there's a price decrease, price elasticity of demand is 2. When there's a price increase, price elasticity of demand is 5, 0.5. And here it is inelastic, here it is elastic. Then we are having another problem, which to believe, because we are having the same change in price, same change in quantity. When we are having same change in price and same change in quantity, still we are getting different values. And so this problem arises because of this point elasticity. In point elasticity calculation, this one, what we are interested elasticity at a particular point. In this case, point A, when there's a price decrease, when there's a price increase, we are interested in point B. So the elasticity values we are calculating depends on the initial point, not the proportionate change. It is the initial point where when you are moving from here to here, one value, here to there, another value. Therefore, we don't agree with this one. It is okay if you are having a smaller change in price. And relatively, a smaller change in price can be measured with price elasticity of demand using the point elasticity equation. This one. This is the point elasticity equation. For that, we have a solution. For that, we say we are having arc elasticity of demand. Arc elasticity of demand. In arc elasticity of demand, what we do, we do not use a particular point. Instead of that, we change our equation little bit. That is P1 plus P2. Right? P1 means the initial price and P2 is the new price. If it is price decrease, P1 will be 20, P2 will be 10. And Q1, that is the initial quantity, 2 and plus Q2, that is the new quantity. Right? So, we can divide this by 2 to get the average, and we can divide this by 2 to get the average, and this 2 we can cut off. And finally, our new estimation formula will be delta Q by delta P multiplied by P1 plus P2, Q1 plus Q2. When it is price decrease, this will be 20 plus 10, this will be 4 plus 2, 6. If it is a price increment, it will be 10 plus 20, 30, and 2 plus 4, 6. So, whether it is increase or decrease, we will be getting the same price elasticity of demand when we use the R elasticity of demand. You can calculate the value. What is the value? Delta Q by delta P. We have the same 2 divided by 10 multiplied by P1 plus P2. That is 20 plus 10, that is 30 divided by Q1 plus Q2, that is 6. Right. So what is the value there? So it will be 1. Arc elasticity of this change, 10 rupee change, will be equal to 1. So we say elasticity equal to 1. It's a unitary. And because of my numerical values, we got into this. Otherwise, we will have different values. We will never get into, we will always not get into 1. In this example, it was 1. But just by looking at even these numbers, this is 2, this is 0.5, this is 1, we can say it is like the middle point. Right here, this is 5, this is 2, so it should be 1. And in arc elasticity, what we do, instead of this point and this point, we get the middle point. That is what we do with the arc elasticity. Right? So we are working with the A-level curriculum, therefore we stop there. So now we learn the point elasticity, and to resolve the problem we are using arc elasticity, that's all. So we get the middle point, we are happy. But if you want to go higher order of economics, we don't agree with this one also. Because when you change your band or the gap between the two prices, your elasticity gets affected. Therefore, we don't use arc elasticity in our calculation. For that, we are using something called differentiation. You may have done. We can use dq by dp, right? And multiplied by the point which we want to calculate. So this dq by dp, in differentiation, you know it is a very small amount of change, right? Which is closer to 0, but not 0. So it's a very small change in Q divided by very small change in P, and which is multiplied by the point we are interested. Then we can calculate exactly at this point. Not this much change. It is very small change, and we calculate the elasticity value at this point. So what we need, we just need only the price equation. And if we have the price equation like QB plus A minus VP, then you can just get dQ dy and VP multiplied by P by Q. So you get the elasticity. But for your level, of course, we forget about that. We just remember point elasticity and arc elasticity. That is enough because we are calculating just the response of quantity demanded due to change in its own price, which can be measured to a point if we want using point elasticity with the formula which I have given there. And if we are looking at a bigger difference in the price, then we are using arc elasticity, which is given here. Right. Now you can get back again to my slides. So this one I wanted to explain whether the price elasticity is 0, 1, or greater than 1. To learn about that, we can use linear demand curve. Of course, even those who have done A-level economics, you learn that linear demand curve, which is having like this exactly equal proportionate, we are having unitary price elasticity of demand, which is wrong. It is not correct because we have unitary price elasticity of demand at a particular point, not exactly at all the places. For that, we can do a very simple exercise. So instead of this, I will put few more points. Let's say this is 25, and here 37.5. So here 75, and this is 12.5. So we are having a few points, right? 12.5, 25, 37.5, and 50. Here we are having 25, 50, 75, and 100. Now, calculate first the elasticity value at this one. Using these numerical values, you just use the point elasticity quickly. So delta Q by delta P, simple one. So easy to calculate, multiplied by P by Q. And let me know what is the price elasticity of demand with these numerical values at point A. Let's say point A, the middle point. For that, you can use either moving from here to here or here to here. Whatever is okay. Because we will be getting this point. Quickly calculate. What is the price elasticity of demand at point A? If you are using these numerical values. Yes, it is 1. It is 1. Simply delta will be wherever. If you are moving from 25 to 37, so it will be 12.5. Sorry, delta Q will be 25. 25 divided by 12.5 multiplied by 25 divided by 50. Simple calculation. So you will be getting 1. So it says it is unitary. That is true. At that point, it is unitary. But can you calculate at point B? You can use point elasticity again, moving from here to here or here to here. Let's say we are moving this way. The price change from 12.5 to 25. The initial point is 12.5 and 75. What is the value? Again, delta Q by delta P, P by Q. It should be something like 0.0. No. Again, you need the calculation. Sorry. Let's calculate it. It is moving from 12.5 to 25. Quantity will be changed from 75 to 50. What is the delta Q? Delta Q is 25 divided by delta P, it is 12.5 multiplied by initial price, which is 12.5 divided by initial quantity 75. Right, these two, and this is 3 by 1. it is 0. Let's say 33. So here it is 0.33. Right? If you put that into point elasticity equation, this will be 0.33 at point B. Now you see the difference. Here it was 1. Now here it is 0.33. That's the difference. To make it a bit more complicated, what you can do, calculate the elasticity at this point. Let's say this is point C. Quickly calculate point C. You can come down here. Original price was 37.5 and now we are decreasing price to 25. What is the change in quantity demanded? That is 25 again divided by price change, that is 12.5 multiplied by initial price 37.5. Here we will be getting 37.5 divided by initial quantities 25. If you calculate, you will be getting something like, right? So this graph clearly says that when you calculate at any point above this middle point, if you draw a graph like this will be 45. Right? So therefore, this is the middle point. In the middle point, we have equal to 1. Any point above the middle point will be greater than 1. Right? So let me clear all this drawing and say any point above this point will be greater than 1. Any point. Right? Elasticity will be greater than 1, any point above this point, and any point below this point will be less than 1. It will be equal to 1. If we do the calculations, finally this will be infinity and this will be 0. So therefore, we can conclude that if it is a linear demand curve, price elasticity of demand is not unitary. It will change depending on the place where it will start from 0 to infinity. And with that, I wanted to say that I previously wanted to discuss the numerical value and the elasticity. So if it is 0, we say price elasticity of demand is inelastic. Inelastic in the sense, if it is 0, it will be perfectly inelastic. There is no any response from quantity demanded. Right? It is perfectly inelastic. We are not changing at all. If it is less than 1, we say inelastic. If it is equal to 1, we say unitary. If it is greater than 1, we say elastic. If it is infinity, we say perfectly elastic or closer to infinity. Right? Then we say a bigger number, we say it is perfectly elastic. So now you can see the numbers, graphically we know, and then with the numerical values we can identify. Whenever you calculate, like in the previous graph, when it is coming like 2, we say it is elastic. When it is 0.3, we say inelastic. Right? So now you can do the calculations and interpret the elasticity values. And the final point in that line is the price elasticity of demand in a rectangular hyperbola. Right? If it is the shape of the demand curve is like this, which is known as rectangle hyperbola, then price elasticity of demand will be unitary, of course. You can calculate this at every point, you will be getting price elasticity of demand equal to 1. So not to worry about here, but when you do higher order economics, of course, you will be drawing this kind of a graph. Whenever you want to insist or you want to put the condition, the behavior of the particular demand is unitary, then we draw the rectangle hyperbola because we know price elasticity of demand along the rectangle hyperbola, any point here, anywhere, it will be equal to 1. That is just for the information. You don't want to